Hello, everyone. Section 110, modeling with functions. This is a section that usually students really don't like because all the problems in it are word problems. I don't think you're going to find that the word problems are too challenging in this section. In fact, a lot of them, all you have to do is just set up the problem and there really isn't anything to solve. Let me show you what I mean. So first of all, our learning objectives in this section is that we are going to need to be able to construct functions from verbal descriptions. It's one of the main things we need to do in mathematics is to be able to take English statements and to write out mathematical statements with it. Math is a language after all. Now, secondly, we'll construct functions from formulas. Now, whether those formulas are like the Pythagorean theorem and we're setting up functions based upon that, or it could be a volume formula that we need to set up a function in terms of x with respect to, it could be an area formula. So we'll be using formulas to construct up functions of x. So first example here, and this would be similar to like the first 5 or 6 problems in the homework. They're all linear functions like this. In this problem, and you'll have to imagine this might be like the budget phone plans that elderly people might use or something, where they still pay an amount for texting fee and stuff like that. So let's say you're choosing between 2, in this case, archaic texting plans, but let's say you're choosing between 2 texting plans. Plan A has a monthly fee of $15 with a charge of 8 cents per text. Plan B has a monthly fee of $3 with a charge of 12 cents per text. We're supposed to express a monthly cost for Plan A, and that's going to be called function f as a function of the number of text messages in a month x. So x is the number of messages you send. So we want to create a function f that's going to represent the cost of that monthly plan. So you'll notice here in my formula I said f of x, that's going to represent the monthly cost for plan A. And I know in plan A it was a $15 base fee plus 8 cents per text. So I represent that, the slope here, 0.08 times x. So that's of course the equal sign there. It's going to equal the cost per text times the number of texts plus the base monthly fee of $15. Now, for the part B of this problem, I said, well, all right, let's express the cost of B. We're going to use a function g to represent that as a function of the number of text messages per month x, and we have the cost. So g of x is going to equal the monthly cost for plan B. And we know it's 12 cents per text plus a base fee of $3. So that's why I'm getting the 0.12x plus 3. Now, in all of these problems in the homework, what they're going to want you to do is find the number of text messages in this problem, or the number of x in general, that the 2 plans are equal to one another. So that's what I'm asking here. For how many text messages will the cost of the 2 plans be the same? Well, I just set plan A equal to plan B, f of x equal to g of x. And when I do that, I would just collect the x's all on one side, and I would always move it to the side where the larger x is. 12 cents minus 8 cents is going to give me 4 cents. So I'll have 15 is equal to 0.04x plus 3. Now, of course, I subtract 3 on both sides, and I get 0.04x is 12. From this step to this step, I just said, well, 12 divided by 0.04, it's going to give me 300. Now, remember, x is the number of text messages sent throughout the month in this case for both plans. So I can say the cost for the 2 plans would be the same with 300 text messages. And then if I wanted to know the cost of either plan, I could plug 300 back in here or over here, and I'd get my answer out. If I plugged 300 here, 0.12 times 300, that's going to be 36. 36 plus 3 is 39. Over in the other one, 0.08 times 300 would be 24. 24 plus 15 is 39. So either way, the plan's charge would be $39 per month for this amount of usage. Now, this is just going back in and making sure you see the slope in this case is always going to be the variable change in the problem. For function f, it was increasing at a rate of 8 cents per text. So x was representing the number of text. We had to put that 0.08 as the coefficient of x. 15 was the y-intercept. That would represent the cost if they didn't send any text messages. So the base fee per month was $15 in that scenario, versus the other case where the base fee was only $3, but the variable case of 12 cents per text message is what ended up making the two cost the same with at 300 text messages throughout the month. Okay, another problem here. What if I say on a certain route, an airline carries 8,000 passengers per month, each paying $100? Okay, now a market survey indicates that for each $1 increase in ticket price, the airline will lose 100 passengers. Now I'm asking you to express the number of passengers per month as a function n, and n is going to be with respect to the function of the ticket price, x. So x is the price of the ticket. All right, so notice how I set up my equation here. Of course, I had to put my function n in terms of x, the number of passengers per month in terms of the price of each ticket. Well, we know that the original amount of passengers was 8,000, okay? But then it told us in the problem that that number of passengers would decrease, or you're going to lose 100 passengers per each $1 increase in ticket price. So it's telling me to let x equal the ticket price. So for example, I know that if they raise the price to $101, they're only going to have 7,900 passengers, because it says for each $1 increase in ticket price, they'll have 100 fewer passengers. If they increase the price to 102, they'll have 7,800 passengers. Okay, how do I represent that? I just say 8,000 minus 100 times the price over the original price of 100. So it's minus 100 times x minus 100. So again, if they raise the price to 101, you're going to be subtracting 100 once. If they raise the price to 102, you're going to be subtracting 100 twice, and so forth. So we know that the number of passengers is decreasing by 100 every time the price goes $1 more than the base price of 100. A lot of 100s in this problem. Now, where did this next page come from? Well, the next page, I'm asking you to express the monthly revenue. What I need you to understand is that revenue, it's always, in this case, it's the number of people that's going to board the plane times the price at which they pay to board the plane. In general, revenue is the number sold times the price that you can sell them for. So in this case, I can say, well, all right, it's the number of passengers, that's my function n, times the price which they pay. We already know that's defined to be x. So the revenue function is not going to be anything other than the function n of x times x. That's what I've done here. The monthly revenue, and this is my function n right here. All I've done is I've simplified it out. I distributed the negative 100 throughout that group. I had the 8,000 minus 100 times x, and then minus 100 times 100. That gave me plus 10,000. That gave me 18,000 minus 100x. Please notice that's where this came from. That is nothing more than my number of passengers formula from the previous page simplified. I can say, well, that's the number of passengers. Revenue is going to equal the number times the price that they paid, which is defined to be x in the problem. So then I would always want a simplified polynomial answer. So I distribute the x through there, and I get that my revenue function would be negative 100x squared plus 1800x. It's a pretty cool problem. Up next here, This is just showing you some common shapes that you should know area and perimeter for. Now, in terms of what you would need to know, let me go ahead and point those out. The area of a square, rectangle, circle, triangle, all certainly you need to know. And then, of course, the perimeter for a square and rectangle is easy. Just the side times 4 for the perimeter, and 2 times the length plus 2 times the width for a rectangle, and a circumference of a square, 2 pi r. So we should know all of that. If you ask anything about a triangle, it's always going to be in terms of area right now, and it's always 1/2 base times height. We would also need to know the volume formula for a cube, where you say all the sides are the same, so it's just side times side times side. For a rectangular solid, where the sides are not the same, you just say, well, it's length times width times height. Pretty easy. Now, is it nice if you know the formulas for the trapezoid, the circular cylinder, the sphere, and the cone? Absolutely. You certainly wouldn't be doing yourself a disservice memorizing those, but it's not going to be mandatory for this class. And in fact, there's not even any problems in the homework assignment for this section using any of those. But just thinking forward to calculus, I certainly use all 3 of the cylinder, cone, and sphere formulas. The trapezoid formula, not too much, and it's pretty straightforward anyway. It's just 1/2 the average of the bases times the height in there. Okay, now, next page. But again, to summarize, you need to know the first 4 and the first 2 here. Let's go ahead and look at a geometric application problem. It says a machine produces open boxes using rectangular sheets of metal measuring 15 inches by 8 inches. The machine cuts equal size squares from each corner. Then it shapes the metal into an open box by turning up the sides. Okay, so we're supposed to express the volume of the box, V, in cubic inches as a function. So how much can that box hold in cubic inches as a function of the length of the side of the square cut? Well, whenever you think about cutting this base, and the base is 15 by 8, in order for it to have a uniform height all the way around, all of those cuts have to be the exact same measurement. Now, please notice that cut that we're saying the height is going to be X in our box, so the height is going to be X. Well, the old width that was 15, it's not just 15 minus X, because I have to fold up both sides of that width of 15 with a height of X. So that's new width is going to be 15 minus 2X. The new length, instead of being 8, it's going to be 8 minus X, so it's 8 minus 2x. Now, I've actually called the length over here 15 minus 2x and the width 8 minus 2x. Really doesn't matter which you call which, as long as you know, hey, okay, the 3 dimensions of the box are going to be the height is x. In this case, the length is 15 minus 2x, and the width 8 minus 2x. Now, we already saw on the previous page that the volume of any rectangular solid is just length times width times height. So that's precisely what I do on the next page. I say volume is length times width times height. We need the volume function in terms of x. So the length, 15 minus 2x, times the width, 8 minus 2x, times the height, x. Now it's just a matter of simplifying that out. And you could get the polynomial. In this case, instead of getting the polynomial, I went ahead and asked you what the domain for this function is. And when you think about the domain, all that you need to remember is that all of the dimensions have to be greater than 0. So the height clearly has to be greater than 0, and the length and the width has to be greater than 0. Well, I know that the length will be greater than 0 as long as the width is greater than 0, because the width is the more restrictive one. I know 15 minus 2x is going to be greater than 0 if 8 minus 2x is greater than 0. So I take the most restrictive portion, the width in this case, and I say that width, it has to be a number greater than 0. So 8 minus 2x is greater than 0. When I subtract 8 on each side of that inequality, that gives me negative 2x is greater than negative 8. I divide by negative 2. Please remember, when you divide by a negative, you flip the inequality sign. That's going to give me x is strictly less than negative 8 over negative 2 is a positive 4. Now, that makes sense. Of course, the height has to be less than 4, because if it's not, then you're going to have a 0 or a negative number for your width. That's impossible. Let's, like for example, assume x was equal to 4. Well, then your width would be 0, because it'd be 8 minus 2 times 4. You can't have a width of 0. So we say, all right, the domain of this volume V function is any x value. We know x has to be greater than 0 to have any height in the rectangular solid. And then it has to be less than 4 for the width to be greater than 0. So the domain of this volume function V is between 0 and 4. Pretty cool. Now, here we're looking at an area application. The area applications typically will give you some rectangular region. Sometimes the rectangular region will be missing one of the sides, or something like they'll say a river blocks one side to where you don't have to fence in that region. This one's more of a straightforward one. It says you have 200 feet of fencing to enclose a rectangular garden. Express the area of the garden A as a function of one of its dimensions x. Okay, no problem. Instantly I say, well, it's going to be a rectangle, so it's going to have two sides that I call the length and two sides that I call the width. I'm wanting to put this function into terms of x, so for now, I'll call the width x and the length y. So now I know the perimeter that I have is 200 feet. So I would say, well, then 2x plus 2y has to equal the perimeter. Well, the perimeter has to be 200. Now, I want to get this function solely in terms of x, so that means I need to solve for y in terms of x. So I solve for y here. Well, I subtract 2x on both sides. 200 minus 2x is equal to 2y. Now, y, in order to solve for it, I would divide by 2 on both sides, and then I can say, ooh, that should be a 2 down there, not an x. That's a typo. Remember that x is a 2. Bad. So 200, and you can see I simplified it correct. 200 minus 2x over 2. 200 divided by 2 is 100. 2x divided by 2 is x. And of course, we had the minus sign there. So that's a typo down there, but this is correct. So what I'm saying is that the length of one side has to be 100 minus x. So then I can go in and say, well, all right, here's my refined drawing. Instead of calling it x and y, I now know y has to be 100 minus x. And so the area, which you would have just said, hey, it's length times width, it's x times y. Now the area with respect to x is going to be x times 100 minus x. Distribute that x through, and you'll get 100x minus x squared. Now, a lot of the problems in the homework, especially in the middle portion, will be just like this, where it's not asking you to solve, it's just asking you to set up an expression to represent the area function in this case. All right, guys, that finishes for what I was wanting to do with this. Please do try the homework assignment in here. And remember, if you run into any trouble, look at what I did out of the problems out of the book. It would certainly correspond to the My Math Lab assignment. But when all else fails, let me know if you have any trouble, and I'll be glad to help.